Section 5.4, more trigonometric graphs. In this section we're going to try to graph tangent, cotangent, secant, and cosecant. And the trick to all of that is knowing when the denominators will be 0. Because whenever the denominator is 0, that means there will be an asymptote in the graph. So here's the graph of sine. And here's the graph for cosine, just as a refresher. So with sine is 0 at multiples of pi. It's at 0, 1 pi, 2 pi, and so on. Cosine is 0 at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So let's look at tangent. Since tangent is sine over cosine, we need to know when the denominator, cosine, is 0, which is all of the pi over 2. Pi over 2, or 3 pi over 2, or the negatives. So that means that all of those values we're going to have an asymptote. Negative pi over 2 and the negatives, 3 pi over 2. Also, if you look at the numerator, at 0, sine is 0 at 0, so we'd have 0 over 1, so that means there's a point right there. If we go into the negatives, then sine would be negative, cosine would still be positive, so it would be a negative over a positive, so it's going down. And as we go to the right here, cosine is going up. Or tangent is going up because sine is positive and cosine is positive. So it's important to notice that tangent has a shorter period than sine and cosine because it only goes from negative pi over 2 to positive pi over 2, which is just pi for the period. And it would repeat all of these intervals, crossing through pi because that's when sine is 0. But it has asymptotes at all of the halves. We're going to look at secant next because it's 1 over cosine. So still cosine is 0 at all of those half pi over 2 values. So that means we're going to have asymptotes at all of those. But in all of these, since it's just 1 over cosine, the denominator, or the numerator, is always 1. We also need to remember that from negative pi over 2 to positive pi over 2, in the unit circle, if you think about it that way, negative pi over 2 is down here at the bottom, positive pi over 2 is up here at the top. Anywhere in between there would be in quadrants 1 and 4, cosine is going to be positive, so cosine is always positive here. Also, cosine is 1 when you at 0. Cosine of 0 is 1. So at 0 we'd have 1 over 1, which is 1. And it's always positive. And as we get close to pi over 2, it gets really small. So you have 1 over something small, which is actually a big number. So it ends up looking like a U that goes through 1. And And then if we were to go to pi over 2 to 3 pi over 2, that would be the other side of the graph. In all of those places, cosine is negative. So, and it becomes negative 1 at pi. So it's going to be the same thing, but in this case it's negative, so it's going down. And you can graph more of this in other areas. It just alternates positive, negative, and it always touches 1 unless the amplitude or something has changed. The period would be full length of 2 pi, because that's how long it takes for each part to happen. So the period is 2 pi. Go back and write for tangent, the period is pi. Now we can look at cotangent, which would be cosine over sine. So now we need to know when sine is 0. Sine starts at 0. Then it would go max out at pi over 2, and it's back at 0 at pi. It's all the multiples of pi. So 0, pi, 2 pi, negative 2 pi, all of that. So when sine is 0, we're going to have an asymptote. So we're going to have all of these vertical asymptotes at multiples of pi. If we look at pi over 2, if you think about the unit circle, pi over 2 is 12 o'clock on the unit circle, which is the point 0, 1. Cosine is 0, sine is 1. So that'd be 0 over 1 for pi over 2. 0 over 1 is 0. And the same could be said for then all of these pi over 2 values. The negatives, positives, 3 pi over 2, all of those. And if you think about from in quadrant 1, from 0 to 2 pi, they're both positive, so we're going to have positive values from 0 to 2 pi. As we get closer to 0, we'd be going to infinity, because that's our asymptote. And also after 2 pi, cosine turns negative, sine is still positive. So we'll get negative values in quadrant 2. So the graph of cotangent just looks like tangent, but going down instead of up. So the period of cotangent is also just pi. And now we can look at cosecant, which is 1 over sine, so we need to know when sine is 0, which we just talked about. Sine is 0 at 0, and all the multiples of pi. And again, we'll think about the unit circle for just a moment. From 0 to pi, that's the top half of the unit circle. In all of those, sine will be positive, cosine will be negative after that. Sine will be negative after that. And also, sine of pi over 2 is 1, so at that point, at pi over 2, it would equal 1 over 1. So we're going to have our point there, and it's very, very similar to the graph of secant. It bottoms out and has these asymptotes. But like we said, after pi, until you get to 2 pi, it's negative that whole time. With its, when sine is -1 at 3 pi over 2, that's the maximum value we would get for cosecant. So you need to see both parts of this for one full period length. That's the upward and downward portion, the positive and negative. So the length of the period for cosecant is 2 pi. And for all of these, it's the same graphing rules. You could have vertical shifts. A number in front would change the amplitude, so it would be like a vertical stretch. A number in front of the x would change the period, so you would divide the period by the number in front. So if we had y equals a, and then it could be any trig function at all. And we could put a k, x minus b plus c, no matter what the trig function is. If it's sine, cosine, tangent, cotangent, cosecant, or secant, the a changes the amplitude. It's a vertical stretch. The k always affects the period. You just divide the period by k, and that's your new adjusted period. B is your horizontal shift. And C is your vertical shift. So here we're going to graph y equals 1/2 cosecant 2x plus pi over 2. Just like in the previous section, you first have to factor out whatever's in front. So let's take out the 2. We get x plus, when we divide by 2, this becomes pi over 4. And we'll do the same thing. There's no vertical shift to start with. The amplitude affects it by 1/2. We'll still call it amplitude. It's a little bit different, but that's okay. The period for cosecant is 2 pi, so our period is 2 pi over 2, which is just pi. And then our horizontal shift is to the left, pi over 4. So since cosecant's related to sine, it has zeros at all the multiples of pi. But all of those are going to be shifted to the left, pi over 4. And since the period was shortened, rather than being a length of 2 pi, it only has a total length of pi. And the 1/2 means that these are our values, so we get our u's in between with our points at 1/2 and -1/2.